determining the probability of events that have logical connectors in them. We can determine the probability of events that have and or statements. The probability of an event that has an and statement, so the probability of A intersection B, or A and B, is equal to the probability of A times the probability of B. You randomly draw a card from a standard deck of playing cards. What is the probability that the card you drew is both red and a queen? We'll start off by saying that A is drawing a red card and B is drawing a queen. Because half the cards in the deck are red, we know that the probability of A is equal to 1 over 2. There are 4 queens in a deck, so the probability of B is 4 out of 52, which is equal to 1 out of 13. Using the knowledge that the probability of A intersection B is equal to the probability of A times the probability of B, we can come up with 1/2 times 1/13, which is equal to 1 over 26. So the probability of drawing a red queen is 1 in 26. We can also determine the probability of an and statement from a Venn diagram. Ms. James asked 30 students the following questions. Do you travel more than 30 minutes to get to school? Do you have a job? The results are presented in the Venn diagram below. What is the probability that a student travels more than 30 minutes to get to school and has a job? Remember, the red circle is representing students traveling more than 30 minutes to get to school, and the blue circle is the jobs. So the area where they are students who travel more than 30 minutes to get to school and have a job is the common area in between. So there are 7 students that fit that criteria. Probability of an event with an or statement. To find the probability of A union B, A or B, we have to add the probabilities of A and B and then subtract the overlapping area. Otherwise, it would be added in twice. So the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. As an example, you're rolling a 6-sided dice 1 time. What is the probability of rolling a number larger than 3 or an even number? So A is rolling a number larger than 4 and B is rolling an even number. So the sample space of A is numbers that are larger than 4. So that's 5 and 6. The sample space for B is an even number. Using the formula for the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A intersection B. So the probability of A, we have 2 possible events out of 6, which is 1 out of 3. The probability of B, we have 3 possible events out of 6, which is 1 out of 2. Then the probability of A intersection B, we can see that there are only 1 entry, the 6, that's in both sample sets. So that's 1 out of 6. So we've got the probability of A, which is 1/3, plus the probability of B, which is 1/2, subtracting the probability of A intersection B, which is 1/6. Convert them all to a common base. It's equal to 4/6 or 2/3. So the probability of rolling a number that is larger than 3 or an even number is 2 in 3, or 2 out of 3. We can also determine the probability of an or statement from a Venn diagram. Using our example again, where Ms. James asked 30 students the following questions. Do you travel more than 30 minutes to get to school? And do you have a job? The result is presented in the Venn diagram below. What is the probability that a student travels more than 30 minutes to get to school or has a job? And if you look at the Venn diagram, travel more than 30 minutes, so that's everything that's in the red space, or they have a job, that's what's in the blue space, and we don't need to count the space in the middle twice, so we simply put 8 plus 7 plus 6, which gives us 21. There are 21 students who either travel 30 minutes to get to school or they have a job out of the total of 30 students. So the probability that they travel or they have a job is equal to 21 over 30, which can be reduced down to 7 out of 10. Note, when you're using a Venn diagram, you can also simply count the number of elements in T and J. Alternatively, we could have said the probability of T, so the probability of travel, is equal to 8 plus 7 is 15 out of a total of 30. The probability of job was 13 out of 30. And the probability of T intersection J was 7 out of 30. We can then use the formula again, which says probability of T union J is equal to the probability of T plus the probability of J minus the probability of T intersection J. And plugging those numbers in, we get 15 divided by 30 plus 13 divided by 30 minus 7 divided by 30. And when we calculate it all out, we end up with 21 over 30 again. Add this to your memory aid. Try the practice questions in the workbook and check your answers against the answer key.